Hello, so in this video I will show you how to train a new language for F5 text-to-speech, F5 TTS. This is a repository and this is a Gradio local web interface. So step one, you record a sample of yourself, the voice you would like to clone.
Bonjour, je suis très content d'être ici. Bonjour, je suis très content d'être ici.
And then the text that you would like to generate. So if you have not figured it out already, this is in French for training a new language in French. So we want to say bonjour, c'est la vie, say hello, it's life. Very quick. And we click on synthesize. So what it will do first, it will do what we call a whisper, speech to text. Then it will use my phrase here to mimic my tone, and the result is here.
Bonjour, c'est la vie.
It's not too bad, it's okay.
Bonjour, c'est la vie.
So by default, the F5 TTS project only comes with Chinese and English language. So I will show you how I added French. So let's start. So of course this method could be duplicated to add any other language. First thing, if you haven't done it already, you go to this GitHub page and you follow the installation instruction to install. So you will choose this method, the local editable method, because this is only with this method that you will be able to train a new language. So I will skip on this because it's quite already well explained. So I'm closing. Okay, so first thing, yes, if you want to fine-tune a new language, the author of this repository already did a Gradio, so a web interface. So you just start it, F5 TTS fine-tune Gradio. Takes a few seconds. And here we are. So you just open a browser and you have this interface. So first you need to choose the type of language. So if it's a Latin language, I will say with characters, you will choose char. If it's a Chinese type, you will use Pinyin, so char. Then you give a name to your project. I will name it Frenchy. And you create a new project. So here we are. So you select your project here, Frenchy char. Then you need some training data, so some audio files. So here you can drop audio files like WAV, MP3 or whatever you have, and it will chunk it in little segment of 15 seconds, and it will transcribe this data in text in order to train the model. So I will just say it's French language. Regarding the audio files and the training data, it's quite important to understand that I will just put one file here. It's an audiobook, and I will click on transcribe. It's quite important to understand that the training material you are using will define the kind of license your model will have. So if you take a closed source training data, then of course your model will be closed to and not usable for commercial use. I mean, if you want to play by the book. None to say that today in the Silicon Valley, many big companies in AI world do not release their training data or do not give any information on that training data. So it's kind of a taboo subject right now in the AI world. For my training data, I will release what I used. So I used an audiobook in the public domain. The person who read it called Bernard. So I took maybe 5 or 6 audiobooks for a total of something like 40 or 50 hours of reading, chunky little pieces. And this one, the usage, you see, is public domain. So there is no limit for this license, and even the reader is not identified. He didn't give his last and first name. I just have the first name is Bernard. So I used only one single speaker. I'm not sure this is the right way to do it. I don't know if you need to have multiple speakers, female and male, or just one speaker. I don't know what is the best, but this is just my trials and errors. So while I was speaking, I just put one file for demonstration. Of course, you will need a lot of files. I think to train a new language, you will need something like maybe, I say, a minimum of 8 hours. Maybe it's very experimental. I'm not sure actually. So I click on transcribe, and if I click on random sample, it will take randomly a sample here.
Et, de mémoire humaine, ce fut là certainement le plus beau succès oratoire de la Société royale géographique.
Alright, and here you have the transcript on the left, so it looks okay. So we'll proceed to the next step. So vocab check if you have some special characters in your language, you will need to add them here. You could click on check vocab. On my specific language, French, there is no specific characters, so I could proceed already to the next step. Then it will prepare my data. It will put all the audio files as well as a transcript in some specific directories, and a CSV file with a transcript of each audio file. So I will click on prepare. It's very quick. So just for the demonstration, I just have 272 samples, which are just to give you an idea with the model, the French model I trained. I have 80,000 samples. So I would just click on train data now. So be sure that you've selected the French model. I mean the model you created before, and then you can try to click on auto settings. Okay, you need to have at least minimum, I think, 20k samples, but just for the demo we have 272. So fine tune, what it does is, if for example you have an existing model and you want to build on top of this model, you want to train this model further, then you will need to click on fine tune and put the path of this checkpoint file here, but in our case we leave it blank because we want to train a new model from scratch, right? F5 TTS base, for me this is the one who worked the best. Learning rate, I didn't touch this. Size per GPU, this is actually the memory that will be used by your model during the training. So you need to adjust this, I guess, to be on the max of the VRAM of your GPU. I will show you a bit later. But by experience for myself, I have 4090 with 24 gigabyte of VRAM. So I put 12,000. And then Epochs, this is a number of cycle you will go through. I just put 1000. The idea is while it's in this training, we could check if the training is going well, and we could check if the sentences are correct. So as soon as you feel that you have a good result, you could stop. So maybe you will go not until 1000, but you will stop at 200, 300, 100, depending on your training material. Then these settings, I had to stop. I don't remember what I put. So warm up, I'm not sure why, but I put 1000 in my last trial. Save per update, I put 2000. So save per update, what it will do is every now and then it will save a checkpoint just in case that your training crash. You will have a checkpoint where you could come back to in case it's crashing. So if you have each checkpoint is 5 gig. So if you have too much checkpoint saved, it will basically fill up your hard drive pretty quickly. Just to give you an example, to train a model, I had to have 200 gigabyte of free space on the disk is a minimum. And this one I put 500. I think this one is related to the last step, so it is how often it will save the last checkpoint. So I think it's better to keep that one small. The precision, I used FP16. The reason I choose FP16 is when I use mixed precision none, the training was too slow. And that's it. I think we're good with this. And we could start the training. Once again, this training will not work properly because the samples is too low. You need at least 20,000. 60,000 is better. 80,000 is even more. Is correct. So let's start. So I will open this window so we could see what is happening at the same time. Yes, we could do this. So it's loading the data set. So something else that we could do is open the Windows Task Manager and see the performances for the GPU. So you could see that I have 24 gigabyte VRAM and I'm using 23.2, and right now it's training. So here you could see that we are on Epochs number 1 out of 1000, and on this round number 1 we are at 25%, and we go to 6 steps per second, I guess. No, 6 seconds per step. I noticed that during the training, after a while, it goes down to 2.5 seconds per step. Sorry. Okay, so you will need to wait. Just to give you an idea, to train 80,000 samples on 100 epochs, it took me like 1 day and a half, so it could be quite long. If you don't have the GPU to do it, you could do it in the cloud too, but I will not detail that here. So right now I will stop the training and I will show you how to load your training file once it's completed. So we'll pretend it's completed now. So once your training is done, so maybe 2 days later, you will have a directory that look like this, so full of checkpoints. And let's say you want to take the last checkpoint because you like it and you think that the performance is quite good. So one good thing to do is to reduce the checkpoint. So you need to your model, your checkpoint is going from 5 gig to 1.3 gig, so it's faster to infer. The downside of this, once you compress the model, you will not be able to train on top of it. So always keep a trace of the non-compressed model, just in case you need to complete the training at a later point. So I will put my path here. It's model last. And then reduced. Then I will click on reduce, I'm not sure. So, and it will generate a smaller file, just like here. So you see it's only 1.25 gigabyte. Then we could try this model. I mean, you could also just try on the full 5 gigabyte. It will work, but it will be slower. So I could click on test the model now. Here in the checkpoint you will put the path of the reduced or non-reduced checkpoint that you want to use. Here you will need to record a sample of your voice, so I just test 1, 2, 3, or the voice that you want to clone. If you want this to go faster, you could put the transcript of what you're saying, test 1, 2, 3, so it's test 1, 2, 3, and then the text that you want to infer, the text that you want to generate here, and you click on infer just to give you a feeling. Yeah, it took about 2 seconds, and here's the result.
Ceci est un simple test.
It means like this is a simple test. Does it look like my voice? Test 1, 2, 3. A little bit.
Ceci est un simple test.
But if you want my view on this, I think it looks like more the voice of the training material. But if I do like a stupid female voice, I mean a silly voice, sorry.
Test 1, 2, 3. Non. Test 1, 2, 3.
So So I took like a high pitch voice and I will try to infer.
Ceci est un simple test.
So we can see and when we can hear that the voice of the inference has a high pitch voice as well. All right, so remember that here we are in the fine-tune interface. So if you want to use your created model in the normal Gradio interface, which is what is the name of it? Sorry. Yeah, F5 TTS Infer Gradio. You will need to rename the file and put it in the correct directory. But personally, I never found where was the file, so I just edited the file infergradio.py, and here at some point you have something called test load model, and I just put here the path of the model. Just be careful, here you have anti-slash at the beginning for some reason, and then the path of the model. Okay, I hope it helps. I also give the source file, I mean the model I trained, the checkpoints, so you can download it and try it if you're looking for French model. The model so far is okay, it's fine, it's working 90% of the time. It's not perfect, so if you want to train on top of it, be welcome. If you want to follow my channel, this will be helpful. Thank you. Bye bye.